Hello everyone, my name is Tom and welcome back to another episode of this game development tutorial. This will be episode 4 and today we will be discussing shaders. So last episode I think we made this vertex array class and so we moved everything, episode 3.5 I believe we moved everything we did in episode 3, which was creating vertex array objects into the engine, and today we are actually going to give those vertex array objects something to do actually inside of the graphics card. So you should look at it like inside of the graphics card like a little algorithm will run, and that algorithm is going to decide what exactly is going to get drawn on the screen. Right now it pretty much looks at the data it's given and it just puts that data straight on the screen without really doing anything to it. What we want to do is we want to add some extra information so that we can give some colors. But later we can also add some actual algorithms to it so that some funny stuff can happen. Well, I don't think we'll actually need that in our game. We probably just need to get some maybe some lighting and otherwise just the colors, some textures. Textures will be another episode, don't know when exactly, but that will be definitely interesting as well. But yeah, let's get started. Let's go to the engine, and yes, so I do want to go straight into the engine. I don't want to do it first in the game and then move it over again. I don't think that is necessary. Right, so a shader or a shader program, it's also called, so I'm just gonna use program here and I'm going to use public class program. Right. So a shader is something that can run an algorithm on the graphics card, but there are multiple types of shaders. And you need to combine them all into one program and then use a certain program. So different shaders handle different things. We'll be using two, a vertex and a fragment shader. A vertex shader is going to decide where the vertices are gonna go on the screen. So if we just run this, yes, there we go. A vertex shader is going to decide where these points are going to be. So we could say that every vertex you get in, just move them over by 1 to the left or something. So then this would go here, I believe, and this would go here, and then this one would go off screen somewhere. That's an algorithm you could run. A fragment shader is our second shader that we are going to make, and that one will decide what colors will be used. So when using a texture, it will sample the texture and see what pixels need to go where. And we can also choose colors with that, and it will see, alright, so this position I want to use this color. And I don't think we'll need anything else. There are a few other ones, I think. Like, oh wait, we haven't imported anything yet. So using OpenTK.graphics.gl. Right, now we have like shader model or something. Parameter shader type. There we go. These are all the types it wants to show me. Definition then. Let's see. Yeah. So vertex shader, geometry shader, a test evaluation. That's like a tessellator, I believe. I don't know exactly how that works, so never work with that. So maybe that's something for later. Anyway, let's actually get started because this episode will be a long one, I think. So, I want all my shaders to have like a standard extension to them. So, I want to define what those need to be. Here. So, all the vertex shaders should have a .ver extension. Something similar should happen for the fragment shaders. Just call them just 3 letters, that's enough, I think. Let's see. Alright, and then I will use a private constructor. It's not lighting up well, alright, that's fine. And then this needs to take in a handle, and that handle is something we want to save. Private handle. Just handle equals handle, and then of course this needs to be a. There we go. So the handle is going to be again something similar that we had with the vertex array objects. When you ask for buffers. So when you ask for a buffer, OpenGL is just gonna give you a number back. Same with programs. So you ask OpenGL for a program, it's just going to give you a number back, like an ID. And that one we will need to store. Alright. And then I want to be able to load programs using a static function. It will need a location, it will need a name, and that's it actually. Alright. So I want it to be that the vertex shader and the fragment shader both have the same name, just a different extension. So, right. Because we are going to need to store these shaders in separate files, I should actually import IO. Alright, yes, so shaders are, like I said, like some sort of algorithm. So you need to write that algorithm. Now, where do we store something like that? Because it's pretty much just going to be something like this. It's going to look quite similar to just this. Well, we are going to store that in like a separate file, and we need to load in that file, and then we need to like build and link that. So that's what we want to do here. So first, if we want to load a file, we should see if the file exists. Now let's just do that ourselves. Does the file exist? And yes, actually, I have prepared some stuff. So in your standard file, so you have this PC, like your drive, users, your name, source, repositories. I think that's the default location, and then the game, and then the game. Like, never mind that this is all Dutch. By the way, I do apologize for that. Alright, and then we're here in the game, so that's in this project, and then we need to go to bin, binaries, debug, and then in here. So your game is going to run from this location. So if you just use relative directory paths, you will need to work from here. So that's why I have put a file called assets shaders right in there. So yeah, do mind that. You could put it at different locations, but then you would have to use absolute paths, and that would become very messy, because then if you would actually distribute your game, then you need to make sure that your users put your assets at exactly that location, and then probably like the username is going to be different on someone else's computer, so it's going to be messy. Just use the relative ones. And yes, you do have to make sure that if you run your game in release in a little bit, in release mode, then nothing is here yet because we haven't done that yet. But if we would run in release mode, then this would all automatically generate, but assets wouldn't. So make sure that you copy assets into release mode or into your final game later. Anyway, so I've prepared two files. Default, let's just get rid of all this stuff. Oh, there is a lot of stuff here. Alright. So this is what the fragment shader looks like, and this is what the vertex shader looks like. I do like to use Notepad++ for this, but obviously you can just use your regular Notepad or something. That's just fine. Anyway, so vertex shader is probably the one you want to write first. So what you need is you need to specify a version for OpenGL. Well, version 3.3.0 is probably okay, but well, there are a lot of other ones, so it doesn't really matter what you use. Just don't use a very new one, because then a lot of users might not be able to run your game because they don't have the latest OpenGL version, and you probably don't need anything that is more advanced than this, for now at least. Maybe if you are some sort of AAA developer, but because you're here, I'm going to assume that you are not. Alright, so location 0 is vec_force, that's a 4-dimensional vector. Position and layout location 1 in, so that specifies that this is information that this shader is going to use, it's going to import, and vec_for colors. Now, maybe now it becomes clear why we need to enable something at init. Well, we need to enable something at position 0, something at position 1, and then 2, and then 3, and so on and so forth. So if we enable position 0, we're really just saying that we are enabling layout location equals 0, and we are enabling layout location equals 1 when we put in 1. And in this case, 0th one is going to be position. So yeah, that makes sense, right? These are all the vertex locations. The second one will be our colors. So that we do need to make sure when we add data that we put colors in first. That is actually important. Because we read data like this from the list. First 0, then 1, then 2. It means that the first one you put in will be the first one that comes out. So the first one that you put in will become location 1, and the second one will become location 2, and so on. Right. There we need to specify something that we want to export out, another 4-dimensional vector. We're going to call that fragment colors. And then we have the main code. This is just the code that runs. So we're going to say gl position equals position. So this is just going to be the position that is actually going to get used. We're just going to copy position. So no algorithms, nothing weird. We could do something like this. vec_for, do like 1, 1, 0, 0. So we're just going to move everything over by 1. Doesn't really make a lot of sense to do that, but there will be some uses for this, and we will get back to this in later episodes. Right, and frag colors, which is this one, is going to get set equal to colors, which is this one. Alright, so what we're doing is we're telling the graphics card here, alright, just use these positions, and then we're saying, okay, we want to export these colors. And then in a fragment shader, we are going to import in vec_for frag colors exactly these colors. Use the same name, that's important. Right, and we will also have a layout out vec_for color. So we're going to export, or we're going to export the color, which is going to be quite similar to this one. It's just going to be the color that GL is actually going to use, and we're going to set this color equal to the color that comes in our main function. So it's quite similar to the vertex fragment. Also specify the version. Okay. Might still be quite confusing, but yeah, in like half an hour of time I can't get too deep into this, and honestly I don't know everything about how shaders work. It's just that copy and paste these and you're probably going to be good, honestly. And if you want a more detailed explanation on shaders, you should look for another video probably. I do recommend that. or go to like a wiki page on shaders. I do actually recommend to get deeper into shaders because they are like a very important part of your game. But yeah, like I said, we need to keep going. Alright, let me see. So what do we want to do now? Right, so first of all, we want to make sure that we know what the location is going to be. For that we are just going to concatenate location, name, vert. So this is going to be the file that represents the vertex shader. Now, something similar to frag, right? And then only this one needs to change. There we go. Yeah, and then we need to check if these files exist. So if file that exists vert location, if this one does not exist or the other one doesn't exist, you should probably say something about that. Right line. Just say something like program files cannot be found. Something like that, and then just return null. Alright, because if we can find the files, then we can read the files, so we might as well just return null right there. Alright, now, if we can read the file, then we should just store the entire file in a string. Just one big string. So what we need to do is file that read all text. There we go. From vert location, and do the same with frag. So we're just going to read the entire file and frag location. Make sure that the line separators and everything is still in here. So you could also do read all lines, I believe, but then I don't think it will keep track of the line separators. So if you then put everything back together into one string, then you will be missing the line separators, and this code might not run smoothly anymore. Something to keep in mind. For shaders, so now for the actual shader, this is just going to be GL and then create a shader. Oh, not a program, create shader. There we go. And then the same here. Oh yes, you do need to specify a shader type on the vertex shader, and the other one fragment shader. Alright, frag shader. Right, now we have the two shaders. So then we can give these shaders their actual code. So what we can do is do shader source, and then we just put in the shader. Again, this works with IDs. OpenGL holds on to its shaders, but you just get an ID to reference it. And then we just put in the entire thing, just the entire string with all line separators and such. Then again, fragment shaders and frag. So we are pretty much doing the exact same thing for vertex and fragment shader, as you have probably noticed by now. Shader source. There we need to compile them. So just like regular code, this is just in plain text, so it needs to be compiled in order to be actually readable by a computer. So compile the shader vertex shader, and then the same goes for fragment shader. Right. Then we can create a program. Create program. There we go. And yeah, so this works again exactly the same, but now we need to combine the shaders with the program. GL attach shader. So we need to put in a program here. And then the shaders, that's going to be vert shader. And then again the same thing for fragment shader. Attach the fragment shader to the program. Alright, then we need to link the program. So that means that everything, like all the shaders are going to get put together and one big solution, pretty much one big what would you call it? Like one big pile of code is going to get created that is sendable and usable by the graphics card. So now we need to just put in program, and then we can delete the shaders. Delete shader. So we're not going to use the shaders anymore. So we might as well delete them right here. Right. Okay. Yes, so now we should see if the program works. So we can validate the program. And we can put in our program. Oh, program. And then we can check if gl.getError doesn't equal gl error. No, that's wrong. Error code dot no error. So if there's not an error, in other words, if there is an error, we want to notify someone. I do think it would be a good idea to write a logger system, but that will be a next episode. Failed to create program. Yeah, first I want to get all the nice things working, and then maybe someday we will do the more boring things. Yes, so if it fails, the program needs to be deleted. And then we already deleted the shaders, so then we can just return null and everything is back to normal. If you don't delete the program and everything fails and you return it, then you will have like a useless program hanging around in memory. Not the greatest. Probably won't hurt too much, especially not if you have a small game running, but still. New and a program. There we go. So this is all you have to do. And this should work now. I do want to add a few like convenience methods in here. So what I want to do is I want to have a public bool valid to see if everything is valid. It's like a getter. I want to have a private setter, and I want to initialize it to true, because when this program is created, we already know from this function, if it is created at all, then it is already valid. It will never create a program with an invalid program. Yeah. Okay, then we want to have something that can delete the program. So public void delete. So what we want to do is we want to do if everything is valid, then we want to delete program, and then the handle. Here we go. And then we want to make everything invalid. Aha. And we also want to be able to use it. Probably for its use. Because if you want to use the program, just like the buffers and such, we first need to bind the program, or in this case, use the program. So if valid, I can do gl.use program. Oh, alright, I can actually get rid of those. Great. Okay, and that's all we need to do here. Now let's go to our engine. I want to go to our game. There we go. And right, so I want to put some data in here now because I want to put in some colors. So let's get these going. So a color will consist of RGBA, like red, green, blue, and alpha values. So that means that we need 4 values per vertex. We have 3 vertices, that means we need 12 floats here. So the first one I want to have red, so red, no green, no blue, and I want an alpha. And then I want a green, and then I want a blue. Right, so 4, 4, 4. There we go. Perfect. And of course, data needs to know how much per vertex. We just set that would be 4 data points per vertex. 4, 4, 4. Right. But if we would run it now, of course, nothing would happen still because we haven't created an actual program yet. So let's do that right over here. So I want to do just program b equals no wait, program load program, and then the location is going to be assets slash shaders. Don't forget this last slash. Right, so it's right here, right? So it's going to go from the debug file, assets shaders. Right, then the name is going to be default, because we want to use those as default shaders. Right, so this should work. And if p is not null, so if it actually did work, then I want to use it. Right, now let's see if this works. And aha! Would you look at that? It works. Great. So yeah, pretty much exactly as expected. So it's just read all of this. So the code goes in here. It will read that position that we put in. So we put in. Wait, I should probably go here. So we put in all those positions at 0, 0, 1. And then we put in the colors here at the first one. So then it's going here, so it's going to read those as position and colors. And it's going to put the positions at positions. Already did that by default, but I guess it doesn't hurt to do it yourself. And then it's going to output the colors again. And the fragment shader is going to read the colors again. And would you look at that? And then I can say, alright, the output color, the final output color is going to be those colors that we put in. And there we go. We have a nice colorful triangle. Great. It's actually quite nice. Right, now we can close everything again, and that will all work. A basic program. So even though this is really bare bones, there's nothing to it actually. It's still quite a bit of code, of course. So you need to do quite a bit of stuff. And well, I hope it has been somewhat understandable. Like, this is not the easiest stuff. I do struggle with this a little bit myself, so it's also not easy for me to explain all of this. Well, but I guess there are some other sources on the internet, luckily, so if you have any questions, of course you can always leave a comment. And maybe if I don't know the answer, I will Google it for you, otherwise you can Google it yourself always. So that's great. Then I think this was this episode. Next episode I don't actually know what we're going to do next episode. I might consider doing textures, but I think next episode it would be better if we did something about this. Like this is a 2x2 frame in which you can draw, and if we make it like a little bit bigger, then well, then we suddenly have a bigger frame, and if we make it larger again, then it just completely moves. So what you want is, if I make this bigger, that the triangle stays in the middle, of course, but now if I do that, the triangle just moves further over to the left. So if I make a big screen, the triangle is somewhere here. Well, you would want it to be somewhere here. Sure, you might want to get that extra space, but you do want everything to be somewhat in the same position still when chasing the screen. I think that's what we're going to do next episode. So, well, until then, have a great day.